kids, Miss Kulkarni here. Let's continue with organic chemistry and let's discuss the addition reactions of alkenes. Are you guys ready for that? Let's move on. As you know, alkenes are the compounds which contain at least one double bond, and that's why we classify those as unsaturated hydrocarbon compounds. The double bond is the one which makes alkenes highly reactive and ready for addition reactions. Now, depending upon what gets added, the addition reactions are classified as hydrogenation, halogenation, hydrohalogenation, hydration, and polymerization. Let's talk about each of the reaction and how it works. The first one is hydrogenation. This is a reaction in which an alkene is going to react with hydrogen, and that's why called as hydrogenation. And what is the product? That is simply an alkane. So let's look at the example which we have. This is a 2-carbon atom alkene, which is ethene, and then hydrogen is reacting with ethene, and what we get is a simple alkane which will be called as ethane in this case. What are the conditions for this reaction to occur? The temperature must be around 150 to 200 degrees Celsius, and of course it needs catalyst, nickel, platinum, or palladium. All these are good catalysts, so any one of that will do. Next type of reactions are halogenation reactions, and as the word halo suggests, that means alkenes are reacting with halogens. And halogens, you know, they are fluorine, chlorine, bromine, and so. And what is the final product? That is an haloalkane, which is disubstituted. So look at again, we got ethene here, and that is reacting with bromine. The double bond opens up and each carbon accepts that one bromine. So we end up getting that dibromoethane. And if you want to label the carbon atom number, that will be 1 and 2. So it's 1,2-dibromoethane. And the reaction conditions are still same. High temperature, about 150 to 200. And we need to have a catalyst, nickel, platinum, or palladium. How about next reaction? This is hydrohalogenation. Hydro stands for hydrogen and halo stands for halogen. So what are we reacting the alkene with? We are reacting the alkene with compounds such as HCl or HBr, hydrochloric acid or hydrobromic acid. What is the final product? That is the monosubstituted haloalkane. So when it reacts with the alkene, which is ethene in this case, hydrogen goes to one carbon and bromine goes to the other carbon atom, and of course the double bond opens up to a single bond. So we get a monosubstituted haloalkane. And what are the reaction conditions? These reactions are so quick, so fast that even they can progress at simple room temperature. Next one is hydration. And the word hydration tells you it is water. So water and alkenes react together and we call the reaction as hydration. What is the end product? The end product is an alcohol, and the method is commonly used actually to synthesize alcohol. Let's look at the reaction. We can write water H2O as HOH, and again we got two parts for the water. One is the hydrogen and other is OH, the hydroxyl group. So when the addition reaction takes place, one of the carbon gets hydrogen and second carbon gets the hydroxide OH group. What are the reaction conditions necessary? We need to make sure there is a catalyst, and the catalyst needs to be phosphoric acid, and also it requires pretty high temperature, about 300 degrees Celsius, and also high pressure. Let's talk about polymerization reaction. In this reaction, alkenes react with itself and they form longer chains which we call as polymers. In fact, there is a branch of chemistry called as polymer chemistry which only studies the polymer formation. Now let's find out how this process occurs. Here is an example, polyethylene. So we have ethene molecules reacting with another molecule of ethene, and that continues on and on till we get a polyethylene molecule. Sometimes we also call that as polyethylene. Here is the reaction of polymerization. So that's our ethene molecule, and we put N here. That means we have many molecules of ethene present, and those are reacting with itself. So the double bond opens up and the molecules react with each other, thus forming a chain. This is the way we represent polyethylene. We put a square bracket and we put N outside the bracket, indicating the chain is extending in both the direction. Now, how do we name a polymer? It's extremely simple. We look at the name of the alkene and we simply add the word poly before that. So for example, if our starting material is a butene and if we end up getting a polymer with that, we are going to call it as polybutene. It's that simple. So we learned now different types of addition reactions in case of alkenes. In next video, we will talk about the applications of all these processes. So I will see you in next part 2 video. Until then, bye bye.